Hi, this is Mr. Ward, and I'm going to talk about some of the problems that I've assigned from Chapter 10, Section 2 on congruent chord theorems. And we're going to talk about, I'm going to give you a couple of hints about each one, and I'm going to ask you to pause the video at each point and try it yourself. If you don't need the hints on it, it's a pretty straightforward problem for you. You can skip on to the next problem. But I'm going to deal with a few right now, and then I'll deal with a few more, perhaps in another video. So number 4, we've been given an equilateral triangle, okay, and it's ABC. It's inscribed, that means it's inside and touching this circle Q. And we're trying to figure out if we conclude that AB, BC, and CA are all equidistant from the center. Well, what do we know about the sides of an equilateral triangle? I'm going to let you think about that for a minute. I'm going to pause the video and then maybe come back and I'll talk about this. So I'm going to assume you paused and now you've thought it through. Hopefully you have noticed that if it's an equilateral triangle, AC, BC, and AB are all congruent, and they're chords. They are chords because they connect different parts of the circle. So that tells us that any segment that we draw that is perpendicular to those congruent segments, those congruent chords, all of these are going to be perpendicular. Those are all going to be congruent. And so Q is equidistant from all of those congruent chords. Chords are congruent. There will be equidistant from the center by Theorem 69. Consider number 5 then. We've got circle P. That means P is the center of the circle. P is also the midpoint of MN. Think about what that means for MP and NP. And MN is perpendicular to AD and BC. So AD and BC are both perpendicular to MN. Think about how you could apply the theorems for this section to prove that ABCD is a parallelogram. And it would probably be useful to remind yourself what some of the ways you can prove a parallelogram, a quadrilateral is a parallelogram. I'll pause the video and then come back. And now I'm going to assume you have paused the video and we'll talk about how to do this. All right, so I'm going to note that since P is the midpoint of MN, then we know that PM and PN are congruent. And that means that P is equidistant to AD and BC, which are chords. Okay, that tells me that BC is congruent to AD. So I have one of the components for proving that ABCD is a parallelogram. So I have opposite congruent sides. If I could also prove that AB and DC were congruent, that would do the job as well. But I don't think I can do that very easily. I might be able to pull that off. But what I can definitely prove, I mean, I could prove that. I could prove that with a couple of radii drawn from P. But what I can definitely prove for sure is that because AD and BC are perpendicular to MN, AD and BC are parallel. And one of our theorems for proving a quadrilateral is a parallelogram is if opposite sides are congruent and parallel. So check, ABCD is a parallelogram. In my next video, I'll talk about 7, 8, and 9.